In this video, we're going to look at double angle and then half angle formulas. And this is a place where you may want to either try to find a sheet online that has all of your trig formulas on one page if you haven't done so already, or you may want to pause the video and write them down so you have them for a quick reference. When I'm working through the examples, I'm not going to always go back to this first page with the double angle formulas. So double angle formulas means that we're multiplying our theta value by 2. So an angle formula for sine of 2 theta would be equal to 2 sine theta cosine theta. So we're taking and finding the sine of 2 theta, and we can write it in terms of cosine and sine of theta, whatever those values are. Cosine of 2 theta has 3 different formulas. One of them is cosine squared minus sine squared. Another one for cosine of 2 theta is 1 minus 2 sine squared theta. And then another one for cosine of 2 theta is 2 cosine squared theta minus 1. And we could derive these two by doing substitutions for cosine squared and then sine squared. And then we have one for tangent. Tangent of 2 theta is equal to 2 tangent theta divided by 1 minus tangent squared theta. The next 3 formulas that we see on our screen are called power reducing formulas. And what a power reducing formula does is it reduces the power of the trig function. The first one has an equivalency for sine squared. It says sine squared is equal to 1 minus cosine of 2 theta, all divided by 2. The second one is for cosine squared of theta. That's equal to 1 plus cosine 2 theta, all divided by 2. And then we have tangent squared theta is equal to 1 minus cosine of 2 theta. All of that divided by the denominator, 1 plus cosine 2 theta. These come in handy specifically in calculus. If you're going to take calculus, where you need to do something called integration for a trig function that's squared, and maybe that's all we have, so we can't do any other tricks, if you will, to help us find the indefinite form of that integral. We could go to these formulas to help us out. And then we're going to look at half angle formulas. So half angle formula means we're trying to find the value of a trig function for half of the angle. Instead of all of theta, it's going to be for theta over 2. Or instead of all of alpha, it's going to be for alpha over 2. So we have tangent of alpha over 2 is equal to the numerator 1 minus cosine alpha over denominator sine of alpha. We could rewrite that as sine of alpha in the numerator divided by denominator 1 plus cosine of alpha. And then if you look at the other 3, we have one for sine of alpha over 2, one for cosine alpha 2, and one for tangent of alpha over 2. Notice we've got pluses and minus in front of that. The sign of this value will depend on where theta over 2 lives. Remember back in chapter 6 in the beginning, we talked about where trig functions were positive and negative, and we use this ASTC to tell us where they're positive. All functions are positive in the first one, sine is positive in the second quadrant, tangent's positive in the third quadrant, and cosine is positive in the fourth quadrant. So we end up using that to help us figure out what's going on with theta over 2 or alpha over 2. So let's look at an example. We've got sine of sine of theta is equal to 3 over 5. They're telling us where theta lives. So in this case, theta is between 0 and pi over 2, which means it's going to be located in the first quadrant. So let's draw a picture of what's going on. So here's my theta value. Sine is equal to the y value divided by the radius. So my y value is 3. My radius is 5. I've got to figure out what this is. Because we've been doing this for several sections now, we know that this is going to be a 3, 4, 5 triangle. We could always use the Pythagorean theorem. X squared plus y squared is equal to the radius squared. So x squared is equal to 25 minus 16. 25 minus 9, which is 16. And so x is going to be the square root of 16, which is 4. Because the way this triangle is drawn, because it's in the first quadrant, we know that value is going to be 4. So let's find the value of some of these trig functions up here. The first one, we're looking at sine of 2 theta. And that's going to be equal to 2 cosine of theta, sine of theta. So cosine of theta is 4 over 5. Sine of theta is 3 over 5. So I'm going to end up with 24 over 25. B is asking us for cosine of 2 theta. So I'm going to pick one of the formulas to use. I'm going to use 1 minus 2 sine squared of theta. So the sine of theta, they gave it to us, was 3 over 5. So 1 minus 2 times 9 over 25. So that's 1 minus 18 over 25. And simplify, this 1 is the same thing as 25 over 25. And if I subtract those fractions, I'm going to get 7 over 25. Okay, let's look at C. C is a half angle formula. So we got to think about where that half angle lives. So if theta is between 0 and pi over 2, then theta over 2 is going to be between 0 and theta over 4. Okay, so we're just going to divide everything by 2. If I divide the middle by 2, I got to divide the ends by 2. 0 divided by 2 is still going to be 0. So we know that this is still going to be in the first quadrant. Okay, let's look at what our formula says. Going back to sine of theta over 2. Sine of theta over 2. We're going to use the positive value here. 1 minus cosine of alpha over 2. So 1 minus 4 over 5 over 2. And we're just going to simplify. So that's going to be 1/5 over 2, which is going to be 1 over 10. And that's 1 over square root of 10. And if we rationalize, we get square root of 10 over 10. D is looking for the cosine of theta over 2. Okay, again, this is in the first quadrant, so we're going to use the positive square root of the formula. And it's 1 square root of 1 plus cosine of alpha all over 2. So 1 plus 4/5 over 2. So that's 9/5 over 2, which is 9 over 10. And then if I take the square root, I get 3 over the square root of 10, or 3 square root of 10 over 10. Okay, E is asking us for the tangent of 2 theta. I can use 2 tangent of theta over 1 minus tangent squared theta. 2 times 3/4 over 1 minus 3/4 squared. Reduce the top. So that's going to be a 3 over 2. Simplify the bottom. 1 minus 9 over 16. So I have 3 halves divided by 7 over 16. which is 3/2 times 16/7. So that's going to give us 24/7. And then F is looking for the tangent of theta/2. And my formula for the tangent of theta/2, I could use the positive square root, remember, because this is in the first quadrant, of 1 minus cosine of alpha over 1 plus cosine of alpha. Positive square root. Cosine of alpha is 4/5. This is going to be 1/5 over 9/5. So simplify. This is 1/5 times 5/9. So 1/9, which reduces to 1/3. So let's look at some of the pieces for number 9. First thing you're going to want to do is draw a picture. We know theta is between pi and 3 pi/2, which puts us down here in the fourth quadrant. Tangent is y/x. So our y here and our x here. Tangent is y/x. Now think about where this lives. That means these values have to be negative. So this needs to be a -4 and this needs to be a -3. And we know this is a 3, 4, 5 triangle. So let's just for fun find part A. So we're going to find sine of 2 theta. And that formula is 2 sine of theta cosine of theta, or 2 cosine theta sine theta. We can multiply in any order, right? Sine of theta is opposite over hypotenuse, or y/r. Cosine of theta is adjacent over hypotenuse, or x/r. So if we multiply, we're going to get 24/25. Now let's do a half angle. Think about where everything lives. We've got to divide everything by 2. And if I divide this by 2, it's the same thing as multiplying by 1/2. So theta/2 lives between 3 pi/4 as our upper bound and pi/2. Okay, so pi/2 to 3 pi/4 is in that second quadrant. So if I wanted to find the solution for part C, sine of theta/2, I'm using my formula. I know this is going to be in the second quadrant, so I'm going to use the positive of it. But if I wanted to find the answer to D, which is cosine of theta/2, cosine is negative in the second quadrant, so I have to use the negative of the formula. So 1 plus cosine of alpha/2. And then we're just going to substitute in our values here. Cosine is -3/5. And I'm working them both simultaneously. Okay, keep in mind this one's going to be a negative. I'm going to circle that so we don't lose it. Okay, going back to the top, sine of theta/2. I'm going to end up with 5 plus 3, which is 8/5/2, which is the square root of 8/10. This one down here, I'm going to end up with 5 minus 3, which is 2/5/2, which is 2/10, or 1/5. And then we could simplify and rationalize each one of those. But it all depends on where that theta value lives. And to find that, you divide everything by 2 to figure out that correct quadrant.